Right now, without feeling a thing, you are moving. The ground under you is turning at over 1,000 kilometers per hour. The planet you are standing on is falling around the Sun at 30 kilometers every second. The Sun itself is dragging you through the galaxy at 230 kilometers per second. And the galaxy is falling toward something so massive we cannot see it. You have never once been still. Not for a single second of your life. Tonight we are going to leave. Not in the way people talk about leaving Earth, with rockets and countdowns. We are going to keep going. Past the moon. Past the planets. Past the last thing the Sun can hold onto. Past the nearest star, past the center of the galaxy, past every galaxy we have ever named. We are going to travel until there is nothing left in front of us. And I want you to notice something as we go. At every step, the thing we just left behind is going to look smaller than you expected. Much smaller. By the end of this journey, everything you have ever known, every person who has ever lived, every war, every song, every ocean, is going to fit inside something too small to see. Let's start with the ground. Look down. Under your feet there are 6,000 kilometers of rock and metal, and at the very center, an iron ball the size of the moon, hotter than the surface of the Sun. It has been cooling for 4.5 billion years and it has barely finished. That heat is what keeps your compass working. It is what keeps the atmosphere from being stripped away. Now look up. The blue you see is not a thing. It is not a dome, it is not a layer. It is sunlight bouncing off a shell of air so thin that if you shrank the Earth to the size of an apple, the entire atmosphere would be thinner than the skin. That is what stands between you and the vacuum. We rise. At 10 kilometers, the height where planes fly, the sky above you is already turning dark. At 50 kilometers, the blue is gone entirely. There is no line, no border, no moment where space begins. The air just keeps thinning until there is nothing left to thin. At 400 kilometers, we pass the space station. It is falling. It has always been falling. It falls around the Earth 16 times a day, and the people inside are falling with it, which is the entire reason they float. Now the planet has edges. For the first time you can see the whole thing at once. The white swirl of a storm over an ocean. The brown edge of a desert. The green that means something is alive. And at the boundary between day and night, a thin band of light that follows the curve of the world. 24 people have seen this with their own eyes and kept going. Only 24, in the entire history of our species. They all said the same thing when they came back. That it looked fragile. We keep rising. 400,000 kilometers out, the moon. It is not the smooth white circle you see from your window. Up close it is grey, and broken, and covered in dust so fine and so sharp that it cut through the astronaut's boots. It smells like gunpowder. It has no wind to smooth anything down, so every footprint left there in 1969 is still exactly where it was pressed, and will be for millions of years. The moon is drifting away from us. 3.5 centimeters a year. Slowly, quietly, it is leaving. There was a time when it hung 3 times larger in the sky. And there will come a time, long after we are gone, when it is too far away to cover the sun, and total eclipses will simply stop happening. We are alive during the exact window when a perfect eclipse is possible. Not before, not after. That is not design. That is timing. And we happen to be here for it. Turn around one more time before we leave. From here, Earth is a bright blue circle you could cover with your thumb. Everything is on it. Everyone. Now we go where it gets quiet. 220 million kilometers away, Mars. It is the color of dried blood, and it is dead. But it was not always. There are riverbeds carved into that ground. There are shorelines. There are minerals that only form in standing water. 3 billion years ago, Mars had a sky and rivers and an ocean covering a third of its surface. Then it lost its magnetic field, and the solar wind took the atmosphere apart, molecule by molecule, and blew it into space. What is left is a planet with a sky the color of rust, where the air is so thin that liquid water would boil and freeze at the same time. But look at what is on it. There is a canyon here that would stretch across the entire United States. There is a volcano, Olympus Mons, that is 2.5 times the height of Everest and so wide that if you stood on it, the slope would be so gentle you would not know you were climbing a mountain at all. You would just be walking for 300 kilometers. And there are our machines. Somewhere on that surface, a rover named Opportunity was built to last 90 days and lasted 15 years. Its last message, before a dust storm covered its solar panels, was interpreted by the engineers as, "My battery is low, and it is getting dark." It is still there. It will be there long after every one of us is gone. We keep going, and the sun starts to shrink. Between Mars and Jupiter there is a gap, and in that gap there is a belt of rock. You have seen it in movies as a dense field of tumbling boulders that a ship has to weave through. That is not what it is. If you were standing on one asteroid in the belt, the nearest other one would be about 1 million kilometers away. You would not be able to see it. You would be alone on a rock in the dark, and the belt would be invisible around you. All of it together, every single asteroid, adds up to less than 4% of the mass of our moon. This is a failed planet. Jupiter's gravity kept stirring the material here so violently that it could never settle into a world. What we are flying through is the wreckage of something that was never allowed to be born. And now the thing that did the stirring. Jupiter. It is so large that it does not orbit the Sun the way the other planets do. The Sun and Jupiter orbit each other around a point that sits outside the surface of the Sun. Everything else in this solar system circles our star. Jupiter and the Sun circle a spot in empty space between them. You could fit 1,300 Earths inside it. Look at the storm. The Great Red Spot is a hurricane wider than our entire planet, and it has been spinning for at least 350 years. That is longer than any nation on Earth has existed with its current borders. Winds inside it move at 600 kilometers per hour, and there is no coastline to break it, no land to slow it down. It just turns and turns. But Jupiter has no ground. If you fell into it, you would never land. You would fall through cloud, then thicker cloud, then a layer where the pressure crushes hydrogen into a liquid metal, and the temperature climbs past anything a machine could survive. There is no surface anywhere. Just a slow, endless transition from atmosphere into something that is not atmosphere anymore. And around this monster, 95 moons. Look at the fourth one. Europa is covered in ice, and the ice is cracked, and the cracks are stained brown. Underneath that shell, kept liquid by the constant flexing of Jupiter's gravity, there is an ocean. Not a lake. An ocean with more water in it than every ocean on Earth combined. It has been dark down there for 4 billion years. It has never seen the sun. And on Earth, we have found entire ecosystems living in exactly those conditions, around vents in the deep ocean floor, feeding on chemistry instead of light. We do not know what is in that water. We have never looked. That may be the most important sentence in this entire journey. Next to it, Io. The most volcanically violent place in the solar system, so squeezed by Jupiter's pull that its entire surface turns itself inside out. There are eruptions here that throw sulfur 300 kilometers into space. And Ganymede, larger than the planet Mercury, with its own magnetic field, the only moon in the solar system that has one. Any of these, orbiting the sun on their own, would be called planets. Here they are just moons. We move on, and the sun is now noticeably dimmer. Saturn. Everyone knows the rings. Almost nobody knows what they are. They are not solid. They are not carved. They are billions of separate pieces of ice, most of them smaller than your hand, some the size of a house, all orbiting Saturn independently at slightly different speeds. From here they look like a solid disk. Up close, they are a blizzard. And they are thin. Almost impossibly thin. The rings stretch 280,000 kilometers across, and in most places they are about 10 meters thick. If you shrank Saturn's rings to the width of a football field, they would be 1,000 times thinner than a razor blade. We are also lucky to be seeing them at all. The rings are young. Possibly only 100 million years old, which means dinosaurs walked on Earth under a Saturn with no rings. And they are dying. Saturn's gravity is pulling them down as a slow rain of ice, and in another 100 million years, they will be gone. We arrived in the middle of the only chapter where they exist. Look at the moon called Enceladus. It is small, white, and covered in ice. And from cracks near its south pole, it is spraying water into space. Actual jets of it, hundreds of kilometers high, feeding one of Saturn's rings. When our spacecraft flew through those jets and tasted them, it found salt. It found silica, the kind that only forms in hot water on a rocky seafloor. It found organic molecules. Somewhere under that ice there is a warm, salty, dark ocean with the chemistry for life, and it is throwing samples of itself into space for anyone to catch. We have flown through them. We have not gone back. And now the light really starts to fail. Uranus. It is lying on its side. Every other planet spins roughly upright as it goes around the Sun. This one was hit by something so large, so early, that it was knocked over completely, and it has been rolling around its orbit ever since. That gives it the strangest seasons in the solar system. Each pole spends 42 years in continuous sunlight, and then 42 years in continuous darkness. A single winter here lasts longer than most human careers. It is also the coldest place in the solar system. Colder than Neptune, which is further out. Something drained the heat out of this world and we still do not fully understand what. And it rains diamonds. Deep in the atmospheres of both Uranus and Neptune, the pressure is so extreme that methane is torn apart, the carbon is squeezed into crystal, and it falls. Diamond rain, drifting down through the dark toward a core no one has ever seen. Neptune. The last planet. 4.5 billion kilometers from home. Sunlight takes 4 hours to get here, and when it arrives it is 900 times fainter than what you feel on your skin at noon. Standing here, the sun would be a very bright star. Nothing more. And yet this is the windiest place we know of. 2,000 kilometers per hour. Faster than the speed of sound on Earth, in a place where the sun barely reaches. Nobody has explained where that energy comes from. Neptune was found with mathematics before anyone ever saw it. Astronomers noticed Uranus was being pulled off course by something invisible, calculated where the something had to be, pointed a telescope at that exact spot, and there it was. We found an entire world by noticing that the numbers were wrong. Now we cross into the outer dark. Past Neptune is the Kuiper Belt, a wide ring of frozen leftovers from the birth of the solar system. Pluto is here, and it is stranger than it gets credit for. Pluto has mountains made of water ice, hard as rock at that temperature. It has a heart-shaped plain of frozen nitrogen that appears to be slowly churning, turning over like something alive. It has a blue sky. It has 5 moons, and the largest one is so big relative to Pluto that they do not orbit each other so much as swing around a shared point, locked face to face forever, each one always showing the other the same side. For 76 years after we found it, Pluto was a smudge of light. Then in 2015 a piano-sized spacecraft that had been traveling for 9.5 years flew past, and for a few hours, we saw it. Then it kept going, because it had no way to stop. Further out, the sun's grip starts to fail. There is a boundary out here that nobody can see. It is the place where the solar wind, the constant stream of particles the Sun has been throwing outward for 4.5 billion years, finally slows down and stops, held back by the pressure of the space between the stars. That boundary is called the heliopause, and it is the real edge of the Sun's territory. Two objects made by human hands have crossed it. Voyager 1 and Voyager 2 launched in 1977. They were designed to last 5 years. They have now been flying for almost 50. They are the most distant things our species has ever made, over 20 billion kilometers away, and they are still sending back signals. The signal is fainter than a wristwatch battery by the time it reaches us. We catch it with antennas the size of buildings. It takes over 20 hours to arrive. Their power is running out. One by one, the instruments are being shut down to save what is left. Sometime in the next few years, the last one will go quiet, and we will lose contact. But they will not stop. They will keep going, silent, for hundreds of millions of years, and they are carrying a golden record with the sound of rain, a heartbeat, greetings in 55 languages, and a piece of bark. Not because we expect anyone to find it. The odds of that are essentially zero. We did it because we wanted the universe to have a copy. And still, we are not out. Because far beyond the Voyagers, wrapping around this entire solar system like a shell, there is the Oort Cloud. It is a sphere of frozen bodies, perhaps trillions of them, so far out that the innermost edge is 2,000 times further from the Sun than Neptune is. Out here the Sun is just another star, brighter than the rest but no longer in charge of the sky. Every comet you have ever seen came from out here. Something nudged one of these frozen objects, maybe a passing star, maybe the tide of the galaxy itself, and it began a fall that took millions of years, until it finally came close enough to the Sun to grow a tail. Voyager 1, moving at 17 kilometers per second, will need another 300 years just to reach the inner edge of this cloud. It will need 30,000 years to come out the other side. We are still, technically, inside our own solar system. Now hold on, because the scale is about to break. The next star is Proxima Centauri, and it is 4.2 light-years away. That number is easy to say and almost impossible to feel, so try this. If you shrank the Sun down to the size of a grain of sand and put it on a table in front of you, Proxima Centauri would be another grain of sand, and you would have to walk 6 kilometers to place it. Between those two grains, nothing. 6 kilometers of empty table. That is what space actually is. It is not the pictures you have seen, full of color and light. Those pictures are the exceptions, the rare bright things, photographed with long exposures and enhanced so you can see them at all. The honest picture of space is an almost completely black frame with a few specks in it. Proxima is a red dwarf, small and cool and dim. And it has a planet. Proxima b is roughly the size of Earth, and it sits in the zone where liquid water could exist. It is the closest possible second home we know of. There is a problem. Red dwarfs are violent. They throw out flares hundreds of times more powerful than anything our Sun does, and Proxima b is so close to its star that it is hit constantly. Anything living on the surface would have been sterilized long ago. Still, it is right there. For light years. With the fastest spacecraft we have ever built, we would arrive in about 70,000 years. That is the nearest one. Pull back further. Now the individual stars start to blur together, and you begin to see the shape of the thing we live inside. The Milky Way. A spiral of a few 100 billion stars, 100,000 light-years across. Our Sun is out here, about halfway to the edge, on a minor arm, doing one lap every 230 million years. The last time our Sun was in this exact spot in the galaxy, the first dinosaurs were appearing on Earth. It has made that trip about 20 times in its entire life. Follow the arm inward. The stars get denser. The sky here would never be fully dark. And at the very center, hidden behind so much dust that we cannot see it with ordinary light, there is something with the mass of 4 million suns packed into a space smaller than our solar system. Sagittarius A star. A supermassive black hole. We have watched stars whip around it at thousands of kilometers per second, dragged by something invisible. In 2022 we finally photographed its shadow. Every large galaxy we look at has one of these at its heart, and we still do not fully understand which came first, the black hole or the galaxy around it. Ours is quiet right now. It is not feeding. But it has flared before, and the evidence is still visible above and below the galaxy, two enormous bubbles of hot gas, 25,000 light-years tall, blown outward by something our galactic center did a few million years ago. We are living in the calm period. Keep pulling back until the whole spiral fits in view. Everything. Every star you have ever seen with your eyes, every constellation, every story anyone has told about the night sky, is inside this one spiral. And this spiral is one of 2 trillion. 2.5 million light-years away, there is another spiral, and it is coming for us. Andromeda is larger than our galaxy, holding perhaps 1 trillion stars, and it is falling toward us at 110 kilometers every second. In about 4 billion years, the two will meet. It will not be a crash. That is the strange part. Space is so empty that when 2 galaxies collide, almost no stars actually hit each other. Instead, the 2 spirals will be pulled apart by gravity, thrown into long streams of stars, and over hundreds of millions of years, they will settle into a single enormous elliptical galaxy. The night sky during that period would be the most spectacular thing any eyes have ever seen. Andromeda growing until it fills half the sky. 2 galactic cores burning. New stars igniting everywhere as gas clouds slam together. There will be nobody on Earth to watch it. By then the sun will have grown hot enough to boil our oceans away. Pull back again. Andromeda, the Milky Way, and about 80 smaller galaxies form the local group. That is our neighborhood, 10 million light-years wide. And the local group is falling toward something. Pull back further and you find the Virgo cluster, over 1,000 galaxies bound together. And the Virgo cluster is part of something larger still, a vast structure 150 million light-years across that we have named Laniakea, a Hawaiian word meaning immeasurable heaven. Every galaxy in Laniakea, including ours, is flowing toward a single point inside it. We cannot see what is there, because our own galaxy is in the way. We just know that something with the mass of tens of thousands of galaxies is pulling. We call it the Great Attractor, which is what you call something when you do not know what it is. Now pull back until the galaxies themselves become dots. And here is where the universe stops looking random. At this scale, galaxies are not scattered. They are arranged in threads. Enormous filaments of matter, hundreds of millions of light-years long, meeting at bright knots where clusters form, and between the threads, vast empty spaces where there is almost nothing at all. It looks like a web. Or roots. Or, if you have ever seen a picture of one, it looks unsettlingly like the neurons in a human brain. That resemblance is a coincidence. It is not a sign of anything. But the reason it happens is beautiful. Both structures are what you get when something spreads outward under simple rules and finds the most efficient way to connect. The empty spaces are called voids, and they are bigger than anything else in existence. If you were in the middle of one, the nearest galaxy would be so far away that your night sky would be completely, perfectly black. No stars. Nothing. A civilization that evolved there would have no reason to ever suspect that anything existed beyond its own solar system. We are lucky. We were born somewhere with a view. And now, the last thing. Keep going outward and eventually you hit a limit. Not a wall. Not an edge you could touch. Something stranger. The universe is 13.8 billion years old. Light travels at a fixed speed. So there is a distance beyond which light simply has not had time to reach us yet. That is the edge of the observable universe. It is not the edge of the universe. It is the edge of what we are allowed to see. And because space itself has been expanding while that light traveled, that boundary is now 46 billion light-years away in every direction. Which means this: you are standing at the center of a sphere 46 billion light-years across. So is everyone else. Every point in the universe is the center of its own observable sphere. There is no middle. There never was. Look at the very edge of ours. Past the furthest galaxies, there is a faint glow coming from every direction at once. It is the oldest light in existence, released 380,000 years after the beginning, when the universe finally cooled enough to become transparent. It is still arriving. Right now. It is passing through you as you listen to this. A small fraction of the static on an old and tuned television was this light, the leftover heat of the beginning, caught by an antenna in your living room. And beyond that glow, we cannot see. Not because there is nothing there, but because before that moment, the universe was opaque. There is no image. There never will be. That is the edge. Now turn around. Everything we passed is behind you. The web of galaxies. Laniakea. The local group. Andromeda. The Milky Way, with its 400 billion stars. Our arm of it. Our Sun, one star among those billions. The Oort Cloud. Neptune, Saturn, Jupiter, Mars. And somewhere in there, too small to find, too small to point at, a blue dot. In 1990, Voyager 1 turned its camera around and photographed Earth from 6 billion kilometers away. In that image, our entire planet is less than a single pixel. A pale blue dot caught in a beam of scattered sunlight. Everyone you love is in that pixel. Everyone who has ever lived. Every empire, every war fought over a piece of it, every song, every language, every idea anyone has ever had. The universe did not have to be understandable. There is no reason that a species on one small rock should be able to work out the age of everything, the shape of everything, and the distance to the edge of what can be seen. But we did. With eyes that evolved to spot movement in grass, and a brain that evolved to remember where food was. We are the part of the universe that figured out how to look at itself. If you made it all the way out here with me, write the word edge in the comments. I want to know who went the whole distance. And tomorrow, when you walk outside and look up, remember that you are not standing under the sky. You are in it. You always have been.